Now we are going to start with the live demo that is related to the phase shifted full bridge DC-DC converter. So in this case, we have the first step that we'll do is define the input parameters of the power stage in order to get the frequency response of the plant. Then we select some types of sensor stage, and finally we select, for example, a PI compensator. After we design the control structure, our control loop, we'll export to PSIM simulation and check the converter response in order to see if our design is stable or not stable. So let's start. The first step is open SmartCtrl. Okay, SmartCtrl. This is the what's new of the new version of the SmartCtrl. In this time, I click on close. This is the start menu. So here we select the option, the DC-DC converter with single loop voltage mode control or the current mode control. So the first step, we have to select the plant. In this case, we select the phase shifted full bridge converter. So this control structure is a single loop that controls the output voltage of the converter. So in this window, we have to define the power stage parameter. So in this example, we introduce, for example, 300 volts for the input voltage. This is the inductance value of the output filter. So this is this inductance. We have the value of the capacitance of the output filter, this capacitor. And also we have to define the leakage. We have to define the leakage inductance of the transformer. So this is the output power of the converter. The int parameter represent the transformer turns ratio. This is the switching frequency. The COSS represent the MOSFET output capacitance, and this is the output voltage in this case. So here we have the steady state, the DC operating point. This is the value. For example, we have the duty cycle for this for the output voltage and input voltage. We have the duty cycle. This is the duty cycle, and we have an effective duty cycle because in this topology there is a loss of duty cycle due to the leakage inductance of the transformers. So also we have information if with this leakage inductance we can achieve the zero voltage switching, for example. Also, SmartCtrl can show if with change, for example, the output power of the converter, I decrease the output power, for example, to 500 watts, you can see how the SmartCtrl detect the conduction mode. So now it's in discontinuous conduction mode. And if I increase the output power, for example, to 3.5 kilowatts, so and click on calculate. So now we are in the continuous conduction mode. So after that, we can click on OK. So in the sensor stage, we have different options. For example, we will select the voltage divider. So also you can, if you have a specific sensor, for example, you can use the equation editor in order to use your own transfer function. So in this case, we select the voltage divider, and here we can define the voltage reference. So in this case, I introduce 66.99 in order, and then click on calculate gain in order to obtain a unity gain feedback. So then I click on OK. And now it's time to define the compensator. So here I select the PI compensator. Also, you can select the equation editor. So in this option, in this case, this example, we select the PI compensator. And here you can define the peak value of the valley value, for example, of the carrier signal. And in this example, it's okay, these values. Okay, click on OK. And now we have to select one point of the solution maps. So if you click on this area, the solution map is open. And now we can select, for example, maybe this point, 2 kilohertz for the crossover frequency and 50 degrees for the phase margin. So now we click on OK, and finally click on OK. So now this is the SmartCtrl windows design. So here we have the transfer function, the frequency response of the open loop transfer function, and here you can see that the crossover frequency is around 2 kilohertz, and the phase margin is around 50 degrees. So here you can see that if I change the value of the crossover frequency and the phase margin, the frequency response is automatically updated. So after we design the control loops, now it's time to export to PSIM simulation. So if you go to this icon, and then we have to click on to PSIM and a schematic option. So here we have first to introduce some name, for example, test number 1, and then click on open and select the S-domain coefficient. So click on OK. Now in PSIM, so now in PSIM, we can see our schematic. This our schematic. This is the phase shift bridge converter. So here we have the leakage inductance of the transformers, This is the inductance of the output filter. We have the sensor stage, and this is our control structure. This is the modulator. Remember that this is a phase shifted modulator, a simple phase shift. So we can put some voltage proof here. For example, this is the phase shift. Phase shift. Also, we have the output voltage. I put a differential voltage proof, for example, in the primary voltage of the transformer. For example, I call the AB, for example, and I put another voltage proof in the rectified voltage here. So right. Okay, I want to change the little bit the total time of the simulation with these parameters. We can change the dead time of the gate signal, and then we can proceed. We can simulate. Okay, so this is the output voltage. Maybe I can move to this part of to the screen. Okay, this is the output voltage. We can see that the output voltage achieved reach the voltage reference, that is 67 voltage. Also, I want to show you the phase shifted. So here is the phase shifted. It's not saturated because the phase shifted in this modulator can be from 0 to 1. So it's not saturated. Also, I want to show you the current through the inductance in the output filter. So we can check that this is this topology is in continuous conduction mode. Okay. And also, I want to show you, for example, the primary and the rectified voltage. So here you can see how we have the loss of the duty cycle due to the leakage inductance. So now I want to show you that, for example, if I change some inputs parameter of the power stage, as I mentioned before, for example, I set 500 watts. Okay, and I click calculate. Now we are in discontinuous conduction mode. So we have click on OK. And now we can select another point, for example, in the solution maps. Okay, in this case, okay, yes. And now we can export the simulation to PSIM. So go to this icon, to PSIM, schematics, and now I want to call you test number 2 and click on OK, open. Now we have select the S-domain coefficients option and click on OK. This is for modulator. Okay. So now again, I want to see the phase shifted. Okay, phase shifted. And click on simulate. Okay, I think I have to close first the, oh no. Okay, I want to change the total time, this one, and now I click on to simulate. So the output voltage reached the voltage reference. So let's see the phase shifted value. Okay, it's not saturated. And now I want to show you the inductance current. So in order to check if the converter is in discontinuous conduction mode. Okay. So this is our live demo for the phase shifted full bridge converter. So thank you for your attention. And this is our information contact. If you have any doubt, don't hesitate to write us or write me.